The steps here for completing the square are listed. We're going to go through each of these steps for the example f at x given above. Put f at x into vertex form. Step 1. Place the terms with literal coefficients in brackets. Step 2. Factor out any coefficient of the term containing x squared. That's that term right there. We need to now factor out the negative 3. So we'll factor that out, placing it in front. What remains is x squared, and then since we had a positive 2x, we'll have negative 2/3 x. We'll leave the negative 1 outside. Step 3. Divide the second coefficient by 2. Square this value, and then add and subtract it to the brackets. I'll do this work off to the side. Negative 2/3 divided by 2 is equal to negative 2/6, or negative 1/3 if we reduce. We now have to square this value, and we end up with positive 1/9. This is the value that I must add and subtract to the bracketed expression. So I have equals negative 3 x squared minus 2/3 x plus 1/9 minus 1/9 minus 1. Step 4. I must remove the subtracted term from the brackets, and I'll have to multiply by the coefficient in front. The subtracted term is this negative 1/9, and I'll have to multiply it by negative 3 as I pull it out of the brackets. This will leave me with negative 3 x squared minus 2/3 x plus 1/9. And then a negative times a negative will make a positive 3/9 minus 1. Step 5. Factor the perfect square trinomial and simplify the like terms. The perfect square trinomial is what we designed in step 4. X squared minus 2/3 x plus 1/9 is a perfect square trinomial. So we take the square root of the first term, x. We take the square root of our second term, 1/9. The square root would be 1/3. And we take the sign from the second term, so minus 1/3. And then we simplify the fraction. 3/9 minus 1 is 6/9. Now we're in vertex form. Our A